Okay, just to put some dates up on your radar, your quiz number 3 is on Monday, a week from today. All right, which means the homework that I just passed out to you is also due on Monday. Okay, and then so you'll take the quiz Monday. The block day of next week we'll do some review, and then the test over derivatives will be on Thursday and Friday next week. Okay, so the 25th and 26th. Everybody good? Okay, in terms of important dates. All right, so now essentially what we're going to do is we're going to start talking about derivatives from kind of a different perspective. In particular, we're going to do implicitly defined equations. So an explicit equation might be written as one variable as a function of another variable. Okay, so y equals 1 over x is in a place where you can just plug in for x and figure out what y is. Okay, whereas an implicit doesn't necessarily have one of those variables by itself. So y equals 1 over x and x times y equals 1, those are equivalent equations. Okay, the points that make the left one true make the right one true. Okay, they're just defined differently. Okay, so essentially not every implicit equation can be defined explicitly. So for example, if we look at this one down here, if I asked you to get that y by itself, get the y by itself in that particular equation, we'd run into some significant challenges. Everybody okay? So the rules we're going to do for finding derivatives implicitly basically means we're going to find the derivative with respect to x of each term. And when that term has a y in it, there's going to be like a dy dx that's part of its derivative. Everybody good so far? All right. So the instructions for all of these equations will be find dy dx. Okay. So if I gave you this equation, so we have x squared minus 2y cubed. I'm just rewriting this in a color-coded way. Okay. We're basically going to take the derivative of each of these terms with respect to x. So what is the derivative of x squared? 2x. And in reality, what we just did was take a derivative of an x term with respect to x. But dx is 1. It doesn't matter. Okay? Now, what about the derivative of 2y cubed? It would be 6y squared, but now because I took the derivative of a term with of a y with respect to x, that would be 6y squared times dy dx. Plus the derivative of 4y would be 4 dy dx. And what about the derivative of 2? 0. Now, you guys, we can ignore the dx dx. I'm fine with you ignoring it. I just wanted us to recognize that we are doing, we are still taking the derivative of that term too, and that but just that it's a dx dx, which would equal 1, which would equal not worrying about it. So now if I want to find dy dx, the next thing I need to do is isolate dy dx. To do that, I'm going to subtract the 2x from both sides first. And then I'm going to recognize that on the left, after I subtract that 2x, we have two different, both the remaining terms have dy dx. So I'm going to factor out that dy dx, and I would be left with negative 6y squared plus 4. So you're going to get all the dy dx's on one side and factor out dy dx, and everything else on the other side. And the minute I do this, I can divide. So now I've got dy dx equals negative 2x over negative 6y squared plus 4. Hopefully this is making some sense. How are we doing? Are we vaguely at least remembering some of this from last year? I hope. Okay, so if I asked you to do this one, my first term would be 3y squared dy dx. The derivative of my second term, 4y dy dx. 14x plus 6 dy dx equals 0, because the derivative of a constant is 0. I'm going to move the 14x over. And undistribute the dy dx of everything that's left. Beautiful equation. This, you guys, this next example we are going to do is not one that I would put on a test. It is much more complicated than what I would put on a test, okay? But we're still going to do it. So the very first thing we need to do, we have this lovely kind of figure 8 graph, okay? So the minute we start making these implicit equations, we all of a sudden end up with things that are not necessarily y is a function of x. And this is a very specific kind of graph. The name of this graph is called a lemniscate. It's one of those words that, like, if you know the answer to that, that feels like you're smart. I don't know. This is a piece of trivia. Okay, you will not be asked the name of this graph on a test. Don't worry. Okay. So what we want to do eventually is get the equation of the line tangent at the point 3, 1. Okay. So we're going to try to find the equation of that line, which means we need to find the derivative in order to find the slope at that point. Okay. So let's find our derivative. So we have 3 times x squared plus y squared equals 100xy. All right. Let's start with the left. If I took the derivative right now, what would be my very first step?
6 times x squared plus
I would use this exponent, which means multiply by the exponent and take it down by 1. So 6 and the x squared plus y squared to the 1 power. Okay, if I do that, I have an inside function of x squared plus y squared, so I'm going to have to take that whole thing times 2x plus 2y dy dx. How are we feeling so far? What would happen on the other side? This is a product rule question, okay? So I would probably, it doesn't really matter, but I would probably separate it out this way, okay? All right, so product rule is fig if, right? So what's my first term? 100y. So derivative of 100x is 100 times the other function in y. Plus, what's the derivative on the other side, or the next term? 100x times the derivative of the second term. The derivative of y is dy dx. How are we feeling? It is, in fact, going to. Yeah. Though I think we could make an argument that, I guess I do tell you to find dy dx. So we do actually have to do that. But, you know, it's fine. It's not as bad as you think. Do you guys mind if instead of calling this 6 times x squared plus y squared, I call it 6x squared plus 6y squared? Like I distribute that 6 in. And then while this looks terrible, and since this is to the 1 power, I'm just going to erase that one. While this next part is going to look terrible, it's maybe not as bad as it looks. Okay, so for instance, I can do that, right? I get 12x cubed. And what is 6x squared times 2y dy dx? It is 12x squared y dy dx. Plus 12xy squared plus 12y squared dy dx. What, Blake? Oh, it is y cubed. Yeah, yeah. Everybody okay? So I'm just going to keep pointing out so here I am kind of, what I'm doing here is trying to move all the dy dx's to one side, to the left, and all the non-dy dx terms to the right. Everybody good? So I have dy dx. I have my 12x squared y, my 12y cubed, and my minus 100x on the left, with the dy dx out front, equals 100y minus 12x cubed minus 12xy squared. All right. Great. I'm going to give you guys just this first one. I want you guys to try to find the equation of both the tangent and normal lines at the point -1, 2. And when you've done it, go ahead and check your answers against mine. A really common mistake, super common, occurs up here, where the original function, this minus xy, so when you take the derivative of that term, there's a bunch of ways to think about it, okay? But when you take the derivative of that term, a lot of times what happens is people will do minus, and then they'll do the product rule, okay? Which is great. And if I did my product rule, I would have y plus x dy dx, okay? But like if I'm doing that, I'm subtracting the entire derivative, and I would need parentheses around that derivative, which would distribute. Another way of thinking about it is I could think of this as x squared plus -1xy plus y squared, and then when I divide that out into -1x as one function and then y is the other, then I don't have to worry about distributing that minus sign through. But it's pretty common that a common mistake is that people would just write this and then and then have a wrong sign somewhere. So if you had a wrong sign in there, that's why. Just again, clarifying expectations. If I ask you for both the normal and the tangent line, make sure you tell me which one's which. Okay? How are we feeling on implicit differentiation? Is this feeling familiar enough? Okay. just because this caused some, in general, on the last homework, problems with trig caused a few problems, so I want to kind of go through and do this one real quick. You guys, what is the derivative of cosine of x minus y?
Negative sine.
We'll start with negative sine, and remember, when we do those derivatives, when we do the derivative of the outer, the inside doesn't change at all, and then we multiply that by the derivative of the inside, which in this case would be 1 minus dy dx. And then plus, and then sine of y, what's the derivative of sine y? Cosine y dy dx. And then the derivative of that square root 2 is 0. All right, from here, I would distribute that sine of x minus y. Are we good up through this point? Okay, from here, if I want to find that slope, I got to do dy dx equals the sine of pi over 2 minus pi over 4 over Guys, what is pi over 2 minus pi over 4? Pi over 4. So all of a sudden this becomes the sine of pi over 4. And then the sine of pi over 4 minus cosine of pi over 4. Or plus cosine of pi over 4. What is the sine of pi over 4? Root 2 over 2 over root 2 over 2 plus root 2 over 2. And that's 1 over 2. We feeling okay? So y minus pi over 4 equals 1/2 x minus pi over 2. That's my tangent. Making the normal. How are we feeling? All right, let's do some second derivatives. All right. Just like before, when we have explicitly defined functions to find the second derivative, you take the derivative of the derivative. So the first thing we need to do is find the derivative. So if I ask you what is the derivative of this function to start, we would say 6x squared minus 6y dy dx equals 0. All right, I would highly recommend that from this step, we simplify because we're taking a derivative again. So to find my second derivative, I'm going to take the derivative of this function. So how do I do x squared over y? What would I do? It would be quotient rule, yeah? Quotient rule being... So my first one would be 2xy. Derivative of the top is 2x times the bottom is y. Minus the derivative of the top, or leaving the top the same, all over the bottom squared. What's the problem with doing this? We have a dy dx in our equation, yeah? Okay, and we don't want dy dx in our equation, so what do you think we should do? We know what dy dx is, yeah? So what we're going to do is take the dy dx out and put in x squared over y in its place. So feel okay? Let's do one more. Why don't you guys go ahead and take the first derivative?
Would be negative cosine x minus.
Yeah. All right, once you found your first derivative, find your second one. So you know, easy. Messy for sure. Could we simplify this more? Sure. Am I gonna make you? Nah. I think it's relatively likely if I ask you about second derivatives, it'll be much more like, say, this one than that one. Everybody good?